Hi everybody. In today's video, we're going to create a new LevelBounds node type that we can drop into a level, define a box that renders in the editor so we can preview it, allows us to move it, and will help bind the camera so that we don't leave the screen when we're playing a level. I guess in addition to that, we're going to be adding a camera to our player, so stay tuned. Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GD script. This is the Metroidvania Forge. Alright, so welcome back. You've hopefully been building a nice level, kind of like I've got here set up. I was just having fun drawing in some background items, and really I didn't finish the rest of the level, so maybe I should do that real quick. But what we're going to do today with this level is we're going to make it so that the camera can move and follow the player, but we're also going to add a simple camera bounds, level bounds system that we can introduce to each level. That'll make it easy for us to define where the camera should be clamped. There's a couple ways we could do this. In the past, what I've done is done things like just look at the size of our tile map and maybe set the camera bounds based on that. That can get somewhat problematic in my opinion, mostly because you'll run into situations, especially with a platformer like this, where maybe you've got things that expand beyond the bounds that you want visible, or maybe you've got a level with no, let's say you didn't have a wall on this left side, like on this main tile map. Okay, maybe it was like this, because we're going to have levels like this where you can leave to the left or the right, and we don't really know what the upper limit should be. And so instead of requiring ourselves to draw things up here to know where the level bounds are, we're just going to make a system that allows us to define that with some simple values, and we'll be able to drop it in, and it'll be easy to work with, okay? And so, make sure you've got a level set up so that you can test this, and then once you do, let's go ahead and begin creating that system. Setting this up, I'm going to actually come down here, and we're going to make a new folder for some of these general resources that we're going to be using throughout our game. So this will be systems, icons, scripts, things that we're going to just be using across the board. So let's go ahead and create a new folder. I'll just call it general. Now within the general folder, I'm going to create a couple new folders. I'm going to create one called icons, so I can just start putting icons in here that we'll use. There's the icons folder. And then I'll create a new folder for general scripts. And we'll be adding other things here in the future as well. Things like our level transition will end up here, a player spawn point, and even more later on in this series. But for now, let's go ahead and open this icon folder in our file manager. And then I'm going to go ahead and open that zip file as well that we have for this chapter. So, if you haven't grabbed that, then grab the chapter 2 zip file. We're just going to bring an icon or two into this folder. Okay, so I'm going to grab all of these. The one icon we're going to use today is this LevelBounds icon. So we're going to have a unique icon here in our scene tree for this node. I'm just going to copy these here into my icons folder. Obviously, we'll be using these other ones later in the chapter. Okay, and once we've got those, we can come over here. And now you can see we've got them ready to go. And since we've got this folder open, the general, let's go ahead and create a new script in our scripts folder. And we'll just call this LevelBounds. Okay, open the script. So this LevelBounds script is going to be unique. We're not going to attach it to any node. It's just going to be like a new node type that we'll add essentially. And we're going to have to do a couple of unique things with this. One thing is this is a tool script. So we're going to have to put @tool at the beginning. What this means is this script will be executed in the editor, okay, as well as in the game. It can do both, but that tool is needed for it to be ran in the editor. And then we'll use an @icon decorator here so that we can go ahead and load this LevelBounds icon. I'm just going to drag and drop that in there. Okay. And then we want this to extend to node 2D. And of course, we should give it a class name, I think. And the class name I will give it will be LevelBounds. There we go. Okay, so now we've set up this basic script. Let's talk about what it needs to do next. Okay, so the basic functionality of this LevelBounds is that we're going to want to be able to add one of these to our level scene tree, and it'll help us define like a bounding box for the camera to stay within. And then we're also going to have it display here in the editor. So we'll have it draw a blue box so we can see where those level bounds are. So it'll have some variables in the inspector that we can set. So some export variables that we can use to control the size of the box. And then most of the other functionality of the LevelBounds script is going to just happen behind the scenes. Okay. But before we can really make full use of the level bounds, we need to add a camera to our player as well. So let's go ahead and open the player. And here in our player scene, we don't yet have a camera. We haven't added that. It's kind of funny that we've gone this far in a series without adding a camera. You know, mostly I would add one right away, but we're trying to introduce these concepts one bit at a time. So let's go ahead and just do a Control A, and the node type that we want is a camera 2D. Whoa, man. Camera 2D. Now, as I zoom out, this camera 2D, you can see it's got this purple box that shows the limits or the, you know, the rendering visible area that it's going to draw or see. We're going to make it a child of our player because this way it'll just follow the player naturally. We don't have to do any special coding to make it follow the player. And if in the future we wanted to have it have smooth following or something like that, it's already a child of the player, so it would smooth follow the player if we enabled that. Okay, we're not going to deal with that particular kind of feature in this chapter, but it's something that would be pretty easy for you to implement. The one thing I am going to do is I'm going to drag this up so that it's kind of centered around his head, maybe. Okay. And once we save this and run our project, we'll now see that the camera should be following our player. Nice. Except I don't know why our player disappeared. Bizarre. Okay, but we can see the camera's working. What did I do? What did I do? What on earth did I ever do? Oh, I've got the visibility of my player turned off right here. I think I was taking a screenshot and didn't want to see him. Okay, let's try that again. Don't turn off the eyeball on your player if you want to see him. Like, that should be a lesson, I guess, right? Okay, there we go. Much better. But now this, having the camera tied to our player, illustrates why we want a level bound setting, because we don't want to be able to see past this edge, especially once we start filling in with nice sky background and stuff. Like, you don't want it to ever show like gray or, you know, whatever, right? We want to get rid of the possibility for this to even happen. But right now, I guess let's go back into our scripts for this level bounds. And now that we have a camera, we're ready to really start implementing this script. Okay, let's begin by defining those export variables that I mentioned. We're going to have two. We want to be able to export a width and a height for our level bounds, essentially, right? And I'm going to use a special type of export. We're going to use the export range. And what this does is it will allow us to, as you can see here, give a minimum, maximum value, the steps that it should go. And depending on the range and the values that you provide here, sometimes it'll give you a little slider to control it. Because we're going to be making these values integers, it's not going to give us the slider, I don't think, but we'll go ahead and set this up. So we're going to have this first variable, by the way, is going to be our width. But I want the minimum width to be the minimum width of my screen, right? 480 pixels is like the resolution I'm targeting. So that's going to be the minimum level size or camera bound size. And the maximum, I'm going to make it pretty big, but I'm going to limit it. I'm going to make it 2048. So it's a multiple of 32. It's going to fit with our tile sizes. Now, this step value, I'm going to make 32 because I want it to match the grid size. You don't have to do this if you don't want to, but I'm going to do that so that it's a little bit easier. This way, you know, if I'm trying to get it to match, I don't have to guess what the number is or whatever. And then you'll notice there's this extra hints after the step. If you look at the tip it's giving us there, I'm going to go ahead and use that extra hint. We're going to make a quote and we're going to put suffix, 2 Fs, and then I'm going to put px. That way that px will display next to our value. We'll know that we're dealing in pixels. Okay, so now this variable is called width. And yeah, it's an integer and I'm going to set it to my minimum value by default, 480. Next, I'm going to export a height. It's basically the same, so I'm going to copy and paste that. There are a few differences. Obviously, our height is 270. That's what I've got it set as. I'm going to leave the maximum as 248, leave the step and the suffix, and then obviously this variable needs a different name, height. And the default, 270. Okay, there we go. We've got some export variables set up. We're going to come revisit these because we're going to want to respond to the changes of these in the editor, but we'll do that when we're ready. For now, let's go ahead and start building the rest of this script. So we're going to use the ready function. So I'm going to add my ready function here. And essentially what we need to do in this ready function are just a couple basic things. First, we want to handle the z index. So I'm going to add a few comments about this. And I want to handle the Z index, particularly when we're in the editor, because I want this to always render on top of everything so that we can see these bounds. It's going to act as a preview for us as we work in our level. The next step is that we need to check for and get a reference to our camera. Okay. That bit of code is going to be a little bit more complex than handling the Z index. And then assuming we find a camera, then we will also update the limits on that camera. Okay. That's the basic functionality that a ready function needs to handle. Now, everything that we need this script to do during our gameplay is going to happen in these lines down here. Handling the Z index and a few other things are going to happen only when we're in the editor. And we can add condition to check if we're in the editor or not, right? And then if we're in the editor, we'll run certain scripts, and if not, we won't. Okay, so that's what we're going to do in the ready function. But before we handle that, I also want to talk about what this does in the editor, right? It's going to draw this preview box. And so we're going to use more Godot built-in functionality to be able to handle that. And so we're going to use a function that's called draw. And this function can be called on pretty much any Node 2D inheriting object. But we only want to do this draw function if we're in the engine or if we're in the editor. So I'm going to use the if engine dot is editor hint. That will return true if we're in the editor. If we are in the editor, then we will draw a box, right? Or technically it's a rectangle. And let's go ahead and actually write this so that we can start previewing this, because it's going to be a big part of the functionality of it. So I'm going to start by defining a rectangle. I'm just going to call it R, and it's a rect2 is the type. And we can just set it equal to and use a constructor to build a new rectangle2 data type. So we'll say rect2. And there's a couple ways that you can instantiate one of these. And you can see once I type the parentheses, we get those. We can create a rectangle2 from another rectangle2, which seems silly. There might be some confusion. That second one looks the same. It's just got an I. So, there's floats and integers. Likewise, in Godot with vectors, vector2s, rect2s, you can make one with floats or with integers. So if you wanted to make a rect2 from a rect2 integer, you could. What we're going to use is that third option, the position and the size. Okay, so what we're going to do is we're going to draw the position we're going to draw at is just going to be vector2.0 because we want this rectangle to just start wherever this node is so we can move it around. And then the size is going to be dictated by the width and the height. So we'll create a new vector2 for the size, and we'll use width and height. Just like that. Okay, so we've defined a new rectangle here. I'm going to go ahead and get rid of that comment. We don't really need that. Now that we've got this rectangle, we can use it to draw a box. So there is a draw rect function, also something that's part of this node. And you can see some of the values that it wants there. It needs us to provide the rectangle to draw colors, and then some optional values like, is it filled, right? Does it have a fill? Is it a solid box, or does it just have an outline? What's the width of the outline, etc. You can see that that filled is default to true. The width is defaulted to -0. And if we look at this draw rect function in the documentation, we can get more explanation as to what that means. So if the width is negative, which is the default, then it will draw a 2-point primitive instead of 4-point ones, which, oh, you can see it means when it's scaled, the lines will remain thin. I don't know. Anyways, so we can use or ignore that width. We're going to use it. So let's start by plugging in our rectangle is the first argument that we need, right? So we can plug in R right there. And then next we need our fill color, or I guess this is just the color. Okay, and so I'm going to just use color. I'm going to define a new color here because there's a color that we're using in our icon. I'd like to match that so that it has some, consistency. So the color we're going to use is, let's see, 0.0 for the red value. And then it says 0.45 on the green. And then the blue, we're going to do 1.0. And then I'm going to give this an alpha of, well, I'll do that later. We'll give it an alpha in just a second. Okay, so we've defined a color. Now, the next value, if it's filled, I'm going to say false because we just want this to draw a border around. We don't want it to fill in. And then we can give it a width. I'm going to give it a width of 3. Okay, so if we save this and look at our level, let's go ahead and select our root node of our level and do a Control A. Because we've defined this script as a class, we can actually find it. So let's look for, was it level LevelBounds. Hey, there we go. It's not picking up the icon just yet, but once we reload the project, it will. So I'm going to go ahead and say create. And now you can see that it drew a blue box. Okay. Pretty awesome. I'm going to go ahead and restart the project so that we get the little icon to show in the scene tree because it's cool. So bear with me just a moment. Okay, cool. There we go. Little LevelBounds. You see how that's nice and distinct in our scene tree? It's pretty obvious what it is, right? I'm going to go ahead and just do another Control A so that you can see if I look for this in here, it'll use that icon here in the add new node dialog, which is nice. It's easy to identify. So I like trying to do this when it makes sense, give a custom icon to some of these things. That's why I've provided a few for this chapter. Okay, so this is cool. I want to just show a couple things. If I move this up the scene tree, like if I put this LevelBounds at the top, you can see that it draws behind the sprites. And I don't really love that because I want to be able to see it. Okay. It looks like it's drawing a thin line behind it, but that's just because I happen to make it match the size of the level. Additionally, if I change the size of the LevelBound, let's say I make it 1000-ish. Why you no worky? There we go. It didn't change the size of that, right? Because we haven't hooked up any code to make that happen. So we need to start working on our script so that we can address those issues. Okay, back into the script we go. Now, the first thing is this handle z-index. That's pretty simple. What we can do, we can set the z-index on a node, but I don't want to have to set it every time we add one of these to the tree. I don't want you to have to come in here and set it. So in the ready function, we can set it. I'm going to go ahead and just say z-index equals, and then the maximum I think is 256. So we're just going to set that. Save it. Then it didn't update here because this was already ready. But if I reload this scene, I'm pretty sure it'll update it. There we go. Ooh, it also updated the size. You notice that? Because what happened is, if we look at our script, it calls this draw function the first time the node is ever created. So because we had already defined a width and a height, it actually called the draw function and drew the correct size. But now if we change it again, let's say I reset it, it's not going to update until I reload the scene, right? I saved it. Let's reload it. Now it updated. But it is drawing on top no matter what the stacking order is. And then we didn't have to go in and manually set that. That z-index is set. You can see that that script we wrote actually changed the value of the z-index in the editor. Kind of cool, right? So let's go ahead and go back into our LevelBounds script. And what we need is we need a way to be able to update this rectangle whenever we change one of these values. Okay. So what we're going to use is we're going to use a variable setter function. So what we're going to do after we initialize this width as 480, we're going to type colon, and then we'll say set equals, and then you can like do a lambda function in here, but I'm just going to write a new function called onWidthChanged, just like that. So that's going to be a function name. I'm going to copy that. So colon set equals onWidthChanged, and then we'll just come down here to the bottom of our script and create this function. And what do we do? You'll notice we've got a little bit of an error up here. And you can see that the error says that it cannot be used as a setter because of its signature. What that means is this line here doesn't work with what this is expecting, because when we call this setter, it's going to pass it a value. So whatever the new width is, it's going to be passed here. So we need to provide that as an argument in our onWidthChanged function. So I'll just say new width maybe. And we know this is an integer because that's the type of value we've defined here. Now that error is gone. We've got a little warning here. It's probably saying something like, yeah, the parameter new width is never used. You might want to remove it or add an underscore, right? I think we've talked about this in the past, but I'm not going to remove the underscore because I am going to use it. So all this function needs to do is first we can set the width because we're not going to do anything special. You could use this to manipulate the value if you needed to, but I'm just going to set width to the new width. Okay, just like that. So yeah, that basically we've written a function that does nothing different, but now we can add additional code on how we want to handle this width change. And really all we need to do is draw the rectangle again. And there's a function, if we're using this draw function here, we can queue a redraw. So, and it's called queue redraw, just like that. Okay, pretty cool. So now if we go back here with my LevelBounds, if I increase this, it's going to, or decrease it, it's going to redraw the rectangle. So now we just need to implement the same thing for our height and we'll be good to go with the redraw. So I'm going to copy this. We'll call it onHeightChanged. And then I'll just go rename a couple of these things, right? We'll call this new height. I mean, technically it would work with new width. It's just would be confusing. And obviously this does need to change, right? We don't want to set the width. We want to set the height with this new value. And then Q redraw. Now we do need to call this function. So I'm going to come up here and say set equals on height changed. Save. Now when we go back here, I should be able to also change the height and have it redraw the rectangle. Now, when I tested this before I recorded this video in my little demo project, I had an issue with moving this and it not updating the rectangle, but it seems to be working fine. And I think it's because I had tested another way to draw this rectangle that I ended up changing anyways. But if any of you run into any problems with that, go ahead and drop it in the comments and I'll take a look and we should be able to resolve it. But what's nice is we do have the ability to move this level bounds. So it's not going to be stuck to this top left corner, right? So if you happen to draw your level way up, starting way up here, you could just take this, drag it up and set the size appropriately, and voila, you've got a level, okay? I'm going to go ahead and set mine back to 0, 0, and I'm going to adjust the width like so. And that's basically what my level will look like, right? And in fact, you can see just by increasing that up by 1 size, because we're going by those 32 pixels, it's like it's snapping to our level, even though it's not. Now, a quick tip too, if you're dragging this around and you're having a hard time lining it up, we could write a script to kind of force it to, but there's also a grid snapping setting in here. And by default, our grid is going to be set to, if I configure it, 8 pixels, which is fine because 32 is a multiple of 8. So we don't really need to change that, right? But now it'll snap to those and make your life a little bit easier if you're moving things around. So you may want to turn that on and off. So I'm going to drag this to the top left corner of my map there. And then I'm going to increase the width just so that it matches. Okay. Turn this grid off. Now we've got a rectangle that draws, and I want to dress it up just a tiny bit, just make it look a little bit cooler. Hardly any cooler, really, honestly. But then we need to handle functionality, because right now it doesn't do anything, right? If I run the game, it's still not constraining the camera. It's not drawing, right? Because we wrote in that condition so that it only draws if we are in the editor. So right now, really all we're doing is we're drawing a blue box in the editor. Cool. But let's go ahead. I want to just do the one little bit of window dressing to make it look a little bit neater, and then we'll move on to making it actually useful. Okay. So I'm going to go back into the script, and I'm just going to come down here to my draw function, and I'm going to do this. I'm going to copy and paste that, change the width to 1. I'm going to take my first color. Earlier I said I might want like a transparency, so I'm going to put a 0.6 alpha on this first rectangle, and then we're just drawing a second rectangle, and I'm going to use the color that's used on the LB inside my level bounds. And so we're going to have a thicker line, and so we're going to have this thicker line that's slightly transparent, and then a thin line. Right, this is 3, this is 1, so it's thin. That is going to be just a brighter blue. And I think the color value I want is 0.75 on the green. And obviously blue is already at 1. So just save that. And if I just reload my scene, it should redraw. Actually, if I change the size, will it redraw it? There we go. Yeah. Okay. So now we've got this handy, fancy little drawing. You can see that this darker blue line is slightly transparent. I'm just having a fun with it. You don't have to do that, but it makes it distinct. It's kind of obvious that this is not one of Godot's normal little things that it draws, because it doesn't draw anything else quite like that. It's usually just a single thin line, right? So there we go. Go ahead and save that. And let's make this thing do its job. Okay, I'm back in my LevelBounds script. And the rest of the code that we're going to need to implement is just going to be in here in our ready function, okay? So the other thing that I want to do, though, is I want to make sure that we only run this next bit of code when we're in the game, not in the editor. And so what we'll do is we'll just say if engine.isEditorHint, then we can return, and then the rest of the code down here will run, right? So if we're in the editor, then function ends at this point. And then anything that you need to work in the editor, if you want to add functionality, you could add up here. Alternatively, you could add it in this little branch, right? We could put the Z index in here or whatever. So I'm going to go ahead and just do it this way, though. So the first thing that we need to do is we need to find our camera. let's go ahead and define a variable for our camera. We could make the camera a variable at the class level, but I don't really want to do that because we're only going to need access to it this one time to set the bounds. Really, this script is only useful when a level first loads, and after that, we don't want it to be doing anything else. So we don't need to store any extra values or anything like that. But the camera, we know, should be of type camera 2D because that's what we're going to be manipulating. And we could try and just find the camera here, but I'm going to leave this declared without setting or initializing that value. And then next, we're going to do a special bit of code because this, if we tried to just get a reference to the camera the way that we're going to, it might fail, especially when the project loads the first time, you know, or maybe if we don't have a player in our scene, there's no camera, then it might fail then as well. So we're going to create a little while loop. And what a while loop does is it continues to run the code until the condition is met. And so I'm going to say while not camera, or I guess until the condition isn't met, I should say, right? So what we're saying here is while camera is null, which we've defined it to be null, then do this. And then as soon as it's not null, it's going to stop doing this loop. And what we're going to be doing in the loop is trying to get the camera. And if we get the camera, then that will cancel out the condition of it being null, right? But in order for this to work properly, we don't want this to lock up the game looking for a camera because we might then prevent the camera from loading. So we're going to make this asynchronous by adding an await. So we're going to await, and we're just going to await get tree dot, and then we can say process frame. So we're just going to do this while loop. We're going to run it every frame, basically, until we find a camera. And what we'll do is we'll say camera equals, and then there's in our viewport, so we say get viewport. If I could type, it would work. So in get viewport, there's a lot of stuff in here. Let's go ahead and just look at this get viewport. It returns a viewport. Okay, this viewport is actually what I want to look at. This is a base class for viewport, which encapsulates drawing and interaction with the game world. So, okay, so the viewport is like our window almost. I mean, there is a window thing. It's not the window, but you can think of it as everything that's rendered inside our game. I like this description. It creates a different view into the screen or a subview inside of another viewport. Child 2D nodes will display in it, and camera 3D nodes will render to it. So what we can do here is there's a function, and I'm not going to find it because it's here. I'm just going to type it out. But it's get camera 2D. You can get the camera 3D. Okay, if you know that you've got a 3D camera or game. But we're just going to use this get camera 2D. And then now let's look at this real quick. Returns the currently active 2D camera. Returns null if there are no active cameras. Okay, so what's going to happen is this is going to run, and it's either going to assign a camera or it's going to assign null. And then if it assigns null, then it's going to do it again. It'll wait a frame and it'll check. And then eventually there will be a camera, and then it's going to be done. It's not going to do this bit of code anymore. Okay. And then once that has happened, we now know that we have a camera. So at this point in the code, we know we have a camera that we can access, and we know it will be of type camera 2D because that's specifically what we're wanting. And if we look at our camera 2D, let's just look at this real quick. It's got a lot of properties, but what we want and what we're concerned with are these limits: limit left, right, top, and bottom. Okay. Let's just go ahead and look at these. This is the bottom scroll limit in pixels. The camera stops moving when it reaches this value, but offset can push it past the limit. We're not going to be using offset, so we don't have to worry too much about that. Okay. Same with limit left, top, right. These are just the limits that prevent it from moving. And in fact, if we look at our player scene and we select our camera, we can find these limits under here. And you can see by default, it's this negative number. So it's not doing anything. But if we want to turn this on and set, a left limit of like 0, top 0, right, we'll put 500 and bottom 500. You see this yellow box that it's drawn? That's now a camera limit. The camera will not be able to leave that box. Okay. But of course, I don't want to set them here because those limits are going to be different per level that we enter, right? That's why we're building this silly little LevelBounds script. Okay, so we're going to come in here and we're going to set these values based on the position of this item and the size and shape of the rectangle that we've defined. Okay, so even if we move this, we need it to be able to take that into account. So our level bounds in this case would start, our left limit would be whatever this value is, and right, top, and bottom, right? Okay. So let's just go back into our script. That's an exhaustive explanation of a simple concept, but I know if you're new, you may not understand what I'm doing otherwise. So I hope that's helpful. But what we're going to start, we'll just start with the limit, with the left limit maybe. And what we can do is we can set it equal to, and this is an integer value, by the way. Okay, so we are going to type int so that if we end up with a float, it'll convert it to an integer for us. And what we want for our left limit is actually going to be the global position on the x coordinate of this box, right? Because if our box is all the way over here, you can see this 393 pixels on the x. That's the left edge, right? By default, I have it at, well, right now it's at -32, but it was at 0. Okay, so if we go into our script, we'll just simply say global position dot x. Now, the top is similarly simple. We just need the y. And that's because the y value, because we're drawing this rectangle from the top left, the y is the top of our rectangle. Okay, so that's easy. Next, we'll get the right limit. Now, the right limit isn't as simple as getting this, but it's pretty straightforward still. We can just get the global position on the x coordinate, and then we just need to add the width. And because our width is already an integer, I'm going to add it outside of the parentheses here. Because otherwise, these values here are floats. Our positions are floats, right? They can have decimals. We've defined our width and our height as integers, okay? So you don't want to add them inside, because then you're going to probably end up with a warning that you're adding a float and an integer or something like that. But that's going to give us our right limit. Okay, it's the global position x plus the width. I'm going to copy this, change this to height. You know where I'm going with this, right? This is y, and this is now the limit bottom. Just like that. And so there we go. We've checked for and gotten a reference to our camera, and we've updated the camera limits. So this code should be ready to go. Why do I have this warning on while not camera? I guess this is something I didn't deal with. Variable camera is used before being assigned a value. Is there a way I can get rid of this? If I give it an underscore, will it ignore that? Because I don't really care. Like, I know that's intentional. Huh. Still there, isn't it? I'm going to just go ahead and finish adding these underscores just because. Bah humbug. Or could we assign it null and get rid of that? Ah. That makes me so happy. If you don't clean these things up, then what's going to happen is, like a month down the road, you're going to have hundreds and hundreds of warnings showing up in your output when you run your project. And then they become meaningless at that point, because now you're just ignoring them, and the majority of them are just stupid little things like that, right? That you're like, yeah, it's fine, I don't care. But you might actually be missing a warning that you want to see if you take that approach. So for that reason, I like to make sure I don't have warnings or errors as I'm writing my code, because then as soon as one pops up, I can go, oh, hey, there's a new warning. Did I do something I shouldn't have? Okay, so there we go. Enough pontificating. Why don't we run this? Should this work? I think this should work. Oh, beautiful. You see, it's already working. I'm at the left edge of my level, and the camera's not going to follow me. Uh-oh. Maybe it didn't work on the top there, did it? We might have an issue with some of my code, but let's check out the right. Right's good. It's just the top. Why is the top not working? Bottom seems to be good as well, because you can see I'm only drawing like one block of black pixel here. But when we look at our world, I've got a couple more blocks below that. So it looks like all of the bounds are working except the top. Did I do something? Oh, well, that would make a lot of sense. Why don't we set this to top? In fact, I'm surprised that didn't break. The only reason that didn't break is because my X and my Y happened to both be -32, so I didn't notice that I was doing that. I'm going to go ahead and save this, and let's just run that project again. Boing, boing. There we go. Now we've got a top limit. Now this is useful because you may come in here, you may be drawing on your level, right? And a couple things might happen. Let's first address this example when I don't have a height here. In fact, I can't show this fully because the original way I implemented this before I recorded the video was to have the camera bounds defined by a tile map layer, which gets painful because then you have to know, like, if you've got multiple tile map layers, which one should you use for the camera bounds? And the issue I was running into is even if I allowed you to assign a tile map layer as the one to use for the bounds, you could still run into an issue like this, right? If I, let me just get the eraser. If I don't have this wall here, then the camera bounds for this, the upper limit of this would be right at the top of that platform. And so your player would jump on this platform and he'd be off the screen, right? Or the camera would not go up any further. In fact, the camera bounds are smaller than the level bounds will be smaller than the camera. So it would kind of mess with that too. But it just doesn't work, right? It just doesn't work very well. Or vice versa. You may have this level like this, and maybe you've got something going on like this up here. And then on our, let's see, on our level 2, maybe we've got like these platforms that just go up higher than the level. You know, there's no way you can get over here, maybe, I don't know, but you want the camera to go all the way up here. Well, then we could just drag our level bounds up, and then this is a good chance to use our grid snapping. Okay, so that might be the upper limit, and then we just change the height. And now if I run the project, I should be able to jump all the way up. Okay. So this way your level bounds can be controlled separately from your tile sheets. It is an extra node that you need to add to every level, but it does provide that flexibility and control, you know, that you wouldn't have otherwise. And it just lets you make decisions on your own. So it's a little bit of a trade-off, but I hope you guys have enjoyed this. Now, in our next video, we're going to be working on level transitions. So we're going to be able to go from this level over to another level. In order to do that, you need to build at least one more level. Actually, I would prefer that you build 2 more levels, if not 3, because we're going to have transitions that go from left to right as well as up and down. And so obviously, if we're going to test a transition jumping up or falling down, we're going to need, you know, a couple different levels with different transition locations. Okay, so that's your homework. Go ahead and work on that. My homework is recording the video, and drop a comment if you've got questions, concerns, feedback on this video. And of course, if you're new, please subscribe so that you can see what's coming next. Thanks for watching, and as always, we'll see you next time. Now, as you guys are working on your levels and your tile sets, if you're part of my Discord community, then I want to invite you to go ahead and share those, especially if you're a Patreon supporter. I'll give you priority on this. If you share the work that you're doing, work that you wouldn't mind me sharing, then I'm going to be putting together kind of like a homework review compilation as part of this chapter. So rather than trying to schedule my videos around reviewing your homework, we'll just make that kind of a fun thing that we can do. It may even be a live stream. We'll see if I can make time for that. But yeah, go ahead and do that. You know, share what you're working on, because I know you guys are doing cool stuff. I already see some of it in my Discord community, but if that's something that interests you and you haven't already done so, share your levels, your tile sheet, whatever you're working on throughout the rest of this chapter, and maybe give me a chance to share it with the rest of the community.